Good afternoon. Alaya, am I audible? শুনতে পাচ্ছ? Visible? It is not clear that am I visible or audible? Okay. হ্যাঁ, তুমি কি দেখতে পাচ্ছ?
আপনাকে দেখতে পাচ্ছি, শুনতেও পাচ্ছি, কিন্তু আমার মাইকটা অফ হয়ে গেছে, ক্যামেরাটা মানে আমার থেকে মাইকটা অফ হয়ে গেছে, অন করা যাচ্ছে না।
ও আচ্ছা, আমার কথা শোনা যাচ্ছে?
হ্যাঁ, আপনাকে শোনা যাচ্ছে।
আচ্ছা, তোমার কথা কিন্তু আসছে না।
তাই ওই যে বললাম আমার মাইকটা অফ হয়ে গেছে। তো
আচ্ছা আচ্ছা
ওটা সেটিং এ গিয়ে অন করতে বলছে, কিন্তু এখান থেকে তা হচ্ছে না।
আচ্ছা, সায়ক বলল আজকে ও জয়েন করতে পারবে না, ওর মোবাইলটা ঠিক নেই। আনাদারলি
মোবাইলে নেট কানেকশন প্রচুর প্রবলেম।
আর অনির্বাণকে আমি বেশ কয়েকবার ফোন করে পাইনি। হ্যাঁ, তো ইট ইজ ওয়ান অফ প্রবলেম। তো ঠিক আছে, আমরা উইথ ট্রায়াল উই বিগান ফর দিস ক্লাস। একটা ট্রায়াল করে আমরা আজকে একটু শুরু করি, দেখি। ঠিক আছে, ঠিক আছে, বেশ। হ্যাঁ, okay, good afternoon. Today I discuss about your in your syllabus nanomaterials, 6th sem syllabus in Calcutta University. It is very improved syllabus and important in this world, and research, especially research background. Nanomaterials is very essential and important to us, discussable, and very important and acceptable. Now it is very clear that nanomaterials, nanoscience is very low and very instrumental. It is one of instrumental discussion. That is, that 10 to the power minus 9 meter, 10 to the power 9 minus 9 meter is called nanometer, and it is the very small in nature. Different type of discussable, different type of instrumental fact, different type of uh, visible or non-visible thing. It's different type and different material subjected to it. Now we discuss about this with our with a PPT. Now screen share and show slide. So I of course show some slide with PPT. হ্যাঁ, যে পিপিটিটা দেখাচ্ছি সেটা কি ভিজিবল দেখা যাচ্ছে? ন্যানো
হ্যাঁ
ম্যাটেরিয়ালস।
দেখাচ্ছি না, লেকচার বাই ডক্টর নূর আলম।
হ্যাঁ, ওকে ওকে, ঠিক আছে। So nanomaterials and applications, especially nanomaterials is very low in length. That is, I have discussed before that I have said before that 10 to the power minus 9 meter in range, and its applications is very important in the, especially different type of technologies and modern technologies and research background. Now we discuss thoroughly it about the materials, nanomaterials and its application, and the classification of nanomaterials, especially classifications is based on the number of dimensions. What is dimensions? Dimensions, that is one dimension only x axis, only being x axis, only one axis belongs, and that is one dimension. And zero dimension, what is zero dimension? Zero dimension means there is no dimension, not of x axis, not of y axis, not of z axis. And a different type of and three dimensional space, that is x, y and z, three axis, having three axis, three dimension. These are different types of dimensions which are not confined in the nanoscale range less than 100 nanometer. Less than 100 nanometer, it is discussable to us. So zero dimensional 0D, one dimensional 1D, and two dimensional 2D, and also three dimensional 3D type of the classified type of nano dimension. And here now see some figure. Two dimensions xy axis, belonging xy axis, two dimensions, nanoscale. Of all of this nanoscale belongs less than 100 nanometer. 100 nanometer, that is 1 nanometer equals 10 to the power minus 9 meter, and 100 nanometer, that is 100 nanometers, that is 10 to the power minus 7, 10 to the power minus 7 meter. So one dimensional field, you know that one of rod, one of rod that axis only belongs in x axis, they lies in only x axis, they are lying less than 100 nanometer length. Nano, so they are called nano wires, nano rods and nanotubes. They are some of they have called thus. And two dimensional in field, it is also belongs in about less than 100 nanometer, and one dimension at nanoscale, that belongs x-axis and y-axis, length along x-axis, and length also belongs y-axis. Totally it has some area, some area such as lx and ly. This is the area, and also only one side of its less than 100 nanometer. These are called nano field. These are called nano field, nano films. Its thickness is very low, so it is also called nano films. So we have discussed about the nano wires, nano rods and nano tubes. They are only one belongs one axis, only one axis, that is x axis, nano rods, nanotube and nano wires. And nanofilms belongs only two axes, that is x-axis and y-axis. All are lying only less than 100 nanometer, that is 10 to the power minus 7 nanometer. All dimensions here, all dimensions x, y, z and nanoscale are belongs the distance less than 100 nanometer. Next, now here one of the classification initially we want to discuss the zero dimensional nanomaterials. What is zero dimensional nanomaterials? Nanomaterials wherein all the dimensions are measured within the nanoscale. All the dimensions are measured within the nanoscale. No dimensions or zero dimension or larger than 100 nanometer. That is larger than 100 nanometer, larger than 100 nanometer, that is a broad scale. We some of measured, we want to measure some of things that larger than 100 nanometer, it is it has not belongs in nanoscale, so it is called zero dimensional nanoscale. The most common presentation of zero dimensional nanomaterials are nanoparticles. Nanoparticles, which are the nanoparticles? Nanoparticles are them. Nanoparticles can be amorphous or crystalline. Nanoparticles is very small, so it is amorphous, very like point one of them, and also crystalline. Crystalline has, what is crystalline? It has some definite shape, and the symmetric shape is called as crystalline. And nanoparticles also be single crystalline or polycrystalline. That is, it may single crystalline or polycrystalline. Now, before discuss that one single nanorods belongs in x-axis, and it may nanofilms and also nanowires. So they are the single and different types of single crystalline. Different crystalline, so they belongs in same category of shape and same category of type, so it is called crystalline. And next third point, be composed of single or multi-chemical elements. That is composed, it has composed by the single or multi-chemical elements. Different type of nanomaterials, different type of, let us consider any materials, any materials made by different type of nanomaterials. Then the nanomaterials, they are composed single only one, or multi-chemical, that is different types of elements, they are composed, exhibit various shapes and forms. They may various shape. Now here one of the figure you have shown that some of nanomaterials are very small, and some of nanomaterials is very larger, so they are not equal. Exhibit various shapes and forms. Various shapes, small shapes or larger shape, and some of shape is spherical, and some of shape are not spherical. So they are they exhibit various shapes and forms, exist individually or incorporated in a matrix. Now, many of nanomaterials are associated with associated. They are belongs associatively. Now here some of nanomaterials here, 1 2 3 4, some of nanomaterials there belongs associately, but here another one single, only single nanomaterials here, only single nanomaterials here. Those are many of nanomaterials may uh, uh, exist individually or incorporately or associatedly in matrix. Be metallic and ceramic or polymeric. Different type of, this is the chemical bonding type nanomaterials. They are metallic, some of metallic, they sometime they are metallic, or they are ceramic or polymeric nanomaterials may be. Now we discuss about the one dimensional nanomaterials. We have discussed before what is one dimensional nanomaterials. One dimensional, that is outside the nanoscale, and this leads to needle like shaped nanomaterials. So it is of course 10 to the power minus 7 meter, that is less than 100 nanometers. It is very needle type and very needle type, that is very small in with one axis, that is x axis. 1D materials include nanotubes. They are called nanotubes, they are called nanorods and nanowires, etc. One dimensional nanomaterials can be amorphous. It may be also amorphous, crystalline, single crystalline or polycrystalline, chemically pure or impure, standalone materials, or embedded means many of materials they are engaged one and another, they are one coincided, one and another materials, they are coincided, embedded in within another in medium. They may have metallic or ceramic or polymeric, this type of different type of one dimensional nanomaterials maybe. Okay, next, two dimensional nanomaterials. We know two dimensional nanomaterials is like nanofilms. They are not confined in a nanoscale. Two dimensional nanomaterial exhibit plate like shape. This type of shape is called nanofilms. We severally we called nanofilms. Two-dimensional nanomaterials include nanofilms. Here it is very important um, discussion or name, nanofilms. Nano layers, that is not only films, different type of films, one of films and another film, different type of films may make nano layers and nano coatings. Only jacket coatings mean nano jackets. 2D nanomaterials can be the characteristic of 2D nanomaterials. Of course, it may be amorphous or crystalline, maybe two types of 2D two-dimensional nanomaterials, and made of various chemical composition. It is very important features that made of various chemical composition, used as a single layer or as multi-layer structures. Layers, we have discussed before, there are many of layers, nano layers, many of layers, many of films it have made by different type of nanofilms, different type of nano layers, etc. Then used a single layer or multi-layer structures. It may be deposited on a substrate, deposited on a substrate. Substrate means a heap type, integrated in a surrounding matrix material. And it also be metallic, ceramic, and polymeric. So two-dimensional nanomaterials we have discussed. Then some important features there are. Two-dimensional materials are substances with thickness of a few nanometers or less. Electrons in these materials are free to move in the two-dimensional plane, but their restricted motion in the third direction is governed by quantum mechanics. And not only quantum mechanics, but it has governed in different type of classical mechanics also. Prominent examples include quantum oils and graphene. Quantum oils means different laws of quantum mechanics, different laws of quantum mechanics, and graphene. Two-dimensional materials are a class of nanomaterials defined by their property of being merely only or two atoms thick. So it is very small in value. So merely one or two atoms thick. Its depth or diameter. Two-dimensional materials is dedicated to publishing fundamental and applied research of the highest quality and impact, covering all aspects of graphene and related two-dimensional materials. If we concise about one-dimensional, what is one-dimensional dimensional material, what is two-dimensional material, what is three-dimensional material, there is another question to ask. So in concise, to come to conclude, in conclusion, we say that two-dimensional materials sometimes referred to as single layers material. Only single layers materials, namely single layer materials, are crystalline materials consisting of single layers of atoms. Two-dimensional materials can generally be categorized as either 2D allotropes and of various elements of compounds consisting of two or more covalently bonding elements. It is chemically bonding. The elemental two-dimensional materials generally carry the Na, that is suffix in their names, while the compounds have A and E, Na, or IDE suffixes. What is the applications? What is the applications of two-dimensional and three-dimensional, especially two-dimensional nanofilms, nanofilms, nanolayers? What is the applications in nature, application in our modern technology? The study of two-dimensional materials is one of the newest and most exciting areas of materials science and engineering science. Two-dimensional materials have the potential to revolutionize and many electronics applications such as solar cells, transistors, camera sensors. Camera sensors means different type of films, type camera sensor, digital screens, and different type of semiconductors. Developed semiconductors. Here some figures are developed: sensors, and measurement device. Here one of these important figure shown to you, and screens, how many type of screens are used as nanofilms, nanoparticles, nanomaterials, two-dimensional nanomaterials, and printed electronically printed. We have used the two-dimensional nanomaterials in printed electronics, and sensor measurement devices. Transistors. In research field, researchers demonstrated and built an experimental graphene chip of single graphene transistor known as frequency multiplier. Integrated circuits, ICs. Graphene has the ideal properties to become an excellent component of integrated circuits. Solar cells, in the field of cells it is used. Graphene turned to be a promising material for photo electrochemical energy conversion in dye sensitized solar cells. Optics, in the field of it is used in the field of optics, that is optical field. Graphene's high electrical conductivity and high optical transparency make it a one of candidate for transparent conducting electrodes. And biomedical field, it is also used in biomedical field. Graphene could soon be used to analyze DNA at record breaking pace. And other applications, IR detectors, composite materials, single molecule gas detection, piezoelectric materials, energy harvesting, graphene nano ribbons, optical modulators, and chemical sensors. From the above discussion, it is concluded that the discovery of graphene and other two-dimensional materials, together with recent advances in exploration techniques, have set the foundations for the manufacturing of single layer sheet from any layer three-dimensional material. They have the potential to play fundamental role in future of nanoelectronics, optoelectronics, and the assembly of novel ultra thin and flexible devices. Graphene is at this time the material most commonly associated with 2D materials. Now, our class, this is our class that we have discussed what is nanomaterials and what is the used of nanomaterials and the classification of nanomaterials, that is one dimensional, zero dimensional, one dimensional, two dimensional, and three dimensional nanomaterials. And also today I have discussed you with PPT that one dimensional nanomaterials and two dimensional nanomaterials thoroughly. Okay, not now. This is our class. Of course, I have discussed the nanomaterials in the basic fields of nanomaterials. Next day, we want to take your class about three-dimensional nanomaterials and also the different uh, uh, type of utilization and experimental ground of nanomaterials. Okay, not so much today.